Taking a quick look at 73, we got some integrals that we want to combine into a single integral. We kind of lead in there. We've done this in class a little bit. The first one is just straight up -5 to 2 on both of them. So with subtraction, we can just subtract. So -5 to 2 of 6x cubed minus -9x. Always keeping that dx in there. I think that would be a completely acceptable answer. It doesn't even say evaluate. Let's look at the next one. The next one says from 5 to 9 of h of x plus from 9 to 3 of h of x. So I always encourage maybe drawing a number line. If we want to go from 5 to 9 on h of x, and then we want to go from 9 to 3, what am I left with? I should just be left with from, basically from, I cancel out all of this, and I've got a negative part of this, so I should really be left with from 5 to 3 of h of x, like the opposite of 3 to 5. We could also write that as 3 to 5 with the negative sign. All right, the next one's got just our straight up integrals again. Pi 2x squared, and this one's also got a pi. So one thing we want to hit is that we can take that constant multiplier and we can put that outside, and we've done that in class with a 3 or a 0.5, and then we can just add the numbers that are inside. 2x squared plus the square root of x squared. Now we could do some simplifying there. We could call that 4x squared plus x if we actually just squared everything. And then the last one. The last one's got a little different. And I would demonstrate this one probably with a graph. So we've got our parabola, left 5, and we want to calculate it from 1 to 4, way over here. It's going to be some huge amount of area. So here's what we can do. We know that the area under any part of a curve, when we move left and right, if we move the bounds left and right, that really won't change. So what if, and we can discuss this in class, but what if I take this and move it 5, and I take these and move them 5? So basically what I'm doing is I'm taking this plus 5, and I'm putting it up here. Would that be the same as the area from 6 to 9 of x squared? Let's take a look at that picture. Let's make it just a little more this way now. So x squared is here, and I want to go from 6 to 9. Do you see how that picture is the same as this picture? So that's the property we're working on here, is taking that plus 5 and actually shifting our graph. So now I can make that the integral from 6 to 9 of x squared dx. And let's just combine them right away now that I've got the bounds the same, plus the square root of x dx. And I would totally encourage you to check it with your calculator. You can get this value on your calculator, this value on your calculator. Then you can try this value on your calculator. And you should definitely see that they're going to be the same.